Alright, so I just want to let you guys know that to clarify this, um, to fill this out, we're going to assume some things. So here we go. First off, we're going to assume that the modulus elasticity for all of them is going to be the same wood. So we're all dealing with Douglas first. So that's going to be the E. The next thing we're going to assume is that the force, the same person is standing. So we're going to say 250 pounds, pound force, right? So we're going to say the same 250 pound person, and it's all the same wood. Also, if you do notice, they do have the picture of the 12-foot span right here, 12 foot. So we're also going to assume that the length is the same for all of them, 12 feet. But be careful, we got to convert that. So if it's a 12-foot length times 12 inches, that's 144 inches, right? So that's the number we got to put for the length. Then the only other thing, I think, for the equation, if you look at delta max, this is the beam deflection, how much it bends or deflects in inches. It's the force, which is 250 pounds for everybody, the length, which is the same for everybody, 144 inches, for all those pieces of wood. When I say all of those, I'm talking about all of these different examples, A through F, right? And then 48, that's the same every single time. The E, sorry, that's a big E. The E is the same because we're dealing with wood every single time. It's the same wood, the Douglas fir. And the only thing that changes then, so everything is the same here. The only thing that changes each time is this I. So if we look right here, the I changes each time. And the I, you were supposed to calculate that yesterday for each one of these. So it's only the I that changes each time. So if we look at that first problem, let's calculate the I here. It's 1.5 by 5.5, and look at the way it's standing up tall, right? 1.5 by 5.5. Let's look at that. So here's the thing. It's 1.5 this way and 5.5 that way. So yesterday you were supposed to find the I of it, and remember, it's base times height cubed divided by 12. And so base is 1.5, the height is 5.5, but we have to cube that, and then divided by 12. And this is, like I said, work from yesterday. And I think it was 21, but let's just do a quick double math check on that. Let's clear this calculator, and let's do quick work. It's 5.5 cubed, so times 5.5 times 5.5, and there we go. That's 5.5 cubed, and we're going to times that by this 1.5 right here. 1.5, enter, and that gets 250 on top, divided by 12 on the bottom, so divided by 12, and it's yeah, I was right, it was 21 or 20.8 if you want to say 20.8 for this particular beam. That only works for this one because it happens to be 5.5 by 1.5, and it happens to be the height is 5.5. So now we know all of it, so we go delta max is equal to 250 pound person. It's the same each time. 144 inches cubed is the length of that piece of wood. It's a really long piece of wood, divided by 48 times the elasticity of Douglas fir, which is 1.8 million, and times I, and that's the one we need right here. That I right here, 20.8, so we wrote it right here. That's the one we need. So it's 20.8. Now this will change on each problem, of course. So just be careful. It'll change here because this one's laying different. So the base is 5.5, but the height is 1.5. So you're going to calculate a new value here. This one is 7.25 for the height and 1.5 for the base. So you're going to get a new value here. So each one of these is going to be a new value, and that's the thing that's changing each time. So sorry I didn't clarify that during the class in Zoom. Let's just do the math real quick, and we'll be done here. Let's see how long this takes. Let's do the top first. Actually, I always recommend doing the bottom first, and I'll show you why in a second. It just makes calculating a little faster. So I'm going to do the bottom first. Here we go. So let's do the bottom. It's 48, then times 1.8 million, right? 1800000, like that. Then times 20.8, that's the last number, and I get 120 with 3 zeros. There we go. and those little commas to help us place. Then let's do the top. So we always start with the cube first. So 144 times 144 times 144. It's going to be a big number. There it is. That's done. Now let's times that by the 250. And I get this huge number, 746, 496, 746, 496, 000. And here's why I like to do the bottom one first, because that top number is already there, right? It's already in my calculator. Then I just push divided by the bottom number, and then I just have to type that one, and I don't have to retype everything. So I type in 1797 120 000, and then we just push equals, and we're done. And the answer is 0.415. So 0.415 inches. That's how much it's going to bend. Almost a half an inch. But that's a long piece of wood. That's 12 feet long, and the person's standing right in the middle, and they weigh 250 pounds. So it's going to bend almost a half an inch, 0.415 inches. Okay, and that's all you got to do each time. This equation over and over again. And just remember, really, for your homework, the only thing changing is this, and you should have calculated those each time yesterday already. And that's it, folks.